In this video, we are going to learn how to solve geometrical problems involving vectors. To solve geometrical problems involving vectors, we have to first transfer all this information into the diagram below so that it will be easier to solve later. Now, vector Bm is given by vector P and vector Ba is given by vector Q. And this information here has already been annotated for us. Next, we will need to transfer this information and the rest of the information below. Given that M is the midpoint of BC and vector Bm equals to vector P, we can conclude that vector MC will also be equals to vector P as well. And the ratio of AD is to DC is given by 2:1. We will use a circle to annotate that these two numbers are ratio and not absolute values. And BD is to BE is given by 5:6, and hence DE will have the ratio 1 as well. Now we will use another symbol here to indicate that these two ratios and these two ratios are not related, and hence we cannot compare the ratio of DE to DC, and vice versa, we cannot compare the ratio of AD to BD. Next, we are asked to express as simply as possible in terms of vector P and Q the following vectors, and we are asked to write down two facts about AM and EC. Now, in order to find vector AM, we will need to use the triangle law of vector addition, and we can use any path from point A to point M. Now, the most direct path will be from A to B and B to M because these two vectors are given. And so, in order to find vector AM, we will use vector AB plus vector BM. And vector AB will be equals to negative vector Q, whereas vector BM will be vector P. And we will have vector P minus vector Q. You can leave your answer as any of these two forms here. Once you have found vector AM, it will be a good habit to write down the vectors on the diagram here. Next, we will find vector BD. We will once again look for the most direct path from B to D. One way to do that is to go from B to A and A to D. We realize that we have vector BA in terms of Q, but we do not have vector AD in terms of P and Q. Whenever we do not have the vector, we can look for it as long as the ratios are given in the question. So vector AD will be equals to 2/3 times of vector AC. And once again, we do not have vector AC, but we can use the triangle law of addition to find vector AC by going from A to B and B to C, because we already have these two vectors. So we will have 2/3 times negative vector Q plus 2 vector P. And we will now substitute it back into the left hand side here, and vector BA will be equals to vector Q, whereas vector AD will be now equals to vector, or rather 2/3 times negative vector Q plus 2 vector P. Simplifying it, we will have 4/3 vector P plus 1/3 vector Q. And do annotate it onto the diagram so that you can use it for later. Next, we are asked to find vector DE in terms of vector P and vector Q. So what is the most straightforward path to go from B to E? Well, you may be looking at the diagram now to look for the most direct path, but you should also refer back to the questions and see what are the type of information that is already given. From the question, we recall that BD will be equals to 5 over 6 times of BE, and earlier on we have already found BD. So the easiest way to find vector BE in terms of vector P and Q will simply to use 6 over 5 multiplied by vector BD. And this will give us 6 over 5 multiplied by BE, which is 4 over 3P plus 1 over 3Q. And simplifying this, we will have 8 over 5P plus 2 over 5Q. To summarize, in order to find vector BE, we can either use previous information given, or we can find the most direct path from B to E. The last vector we have to find is vector EC. So we have to find the most straightforward path once again from point E to point C. And we know that we can use E to B and B to C because we have all these vectors found already. So we will use vector EB plus vector BC. And vector EB was found earlier, and it will be the negative of vector BE, which is negative of 8 over 5 vector P plus 2 over 5 vector Q. And BC is actually 2 vector P. And simplifying this, we will have 2 over 5P minus 2 over 5Q. Whenever we are asked to write down two facts about two vectors, we will first look at whether these two vectors are parallel or collinear. When these two vectors have totally different letters, we will say that they are parallel. When the two vectors share a common letter, we will say that these two vectors are collinear if one of the vector is equals to k times the other vectors. To recall, when two vectors are equal and multiplied by a scalar multiple here, we know that these two vectors must be parallel, and since they share a common letter, we know that these 3 points, point A, point B, and point C must be collinear. That means they lie on a straight line. The other facts that we have to look out for will be the magnitude of vectors AM and vector EC. And let us look at how we do that now. First, we have to find vector AM. And luckily for us, we have already found vector AM at the start of the question, and vector AM will be equals to P minus Q. Next, we have to find vector EC, and we have found vector EC previously as well, and it is equals to 2 over 5P minus 2 over 5Q. We know that if two vectors are parallel, we will have to show that vector AM will be equals to k times of vector EC, or vector EC equals to k times of vector AM, which means that we have to show that AM over EC will give us a constant number k. And how do we do that? We will look at the coefficient of AM and the coefficient of EC. And we will have 1 divided by 2 over 5, and it will give us 5 over 2. Next, we will look at the coefficient of Q for AM and the coefficient of Q for EC. And we will have negative 1 divided by negative 2 over 5, which is equals to 5 over 2 as well. And since the coefficient for both vector P and vector Q divide to give us the same constant number, we can conclude that vector AM will be equals to 5 over 2 times vector EC. And what does this tell us? Yes, first it tells us that AM is parallel to EC. Since vector AM and vector EC, they do not have any common letters, we know that they cannot be collinear. The points cannot be collinear, and so AM is parallel to EC but not collinear. Secondly, we know that AM is 5 over 2 times the magnitude of EC. Once again, in order to write down two facts about two vectors, you first have to show this: whether one of the vector is a scalar multiple of another vector. Because by showing this, you will be able to see whether the vectors are parallel or whether the points are collinear, and whether the vector is how many times the magnitude of the other vector. And so this is how we solve geometrical problems involving vectors.